Hi, good afternoon, everyone.
Good afternoon, Professor.
How are you, Sapphire? Hey, I've been, I just didn't realize that my microphone was
Afternoon.
muted. Hey, good afternoon, Kadir. And with my microphone being, muted, I just kept on talking for a while. How silly that was. Good afternoon, Alicia. Hey. Okay, good. I see 8 people here, 8 people, and let me check how many are there in the forum. And I see 9 people. So one person still needs to join. All righty. So today we are moving on. So I'm sharing my screen right now. Okay. All righty. So we're done with the topic 2, financial statements, as of the last class. And then, so you had your first quiz. The last weekend. I mean, the just past weekend. So we're moving on to topic 3 today. And actually, topic 3, we have done it already. We have done a lot of, uh, uh, we have done a lot of topic 3 already in topic 1. Why? Remember, in uh, in house value example, right? The house value, right? Example. I don't know. House value. Yeah, house value. What else? Uh, Basically, uh, we peeked into the concept of compounding, right? Right. If you remember, right, um, the house value actually, grew through compounding, and that was the reason why we talked about, geometric average, right? Because there is a compounding effect, right? In something that grows. Uh, I mean, the reason we remember we talked about, uh, the difference between the holding period return versus annualized return is because annualized return is not the simple average uh, of annual returns. What's going on here? There's always some kind of some small home improvement work going on. I believe. Um, from uh, from the apartment right above my head or from somewhere. Um, and we understand uh, because there is, because of the what's going on. Oh, I can change the color here. I see. That was the one. Okay, for now. Uh, so because of the compounding effect, we had to use geometric average. Oh, oh. Excuse me a second. There's so much noise. Oh, Can you guys hear this noise? Hmm? All right. So sorry about the noise. Some. All righty. So um, uh, we also understand that in also this was discussed in topic one, that uh, the market in the capital market, right? Right. Capital market is what? You understand the difference between capital market and money market, right? Uh, Money market is basically, lending money, right? Lending or borrowing money within 1 year maturity, right? Whereas capital market is, a financial market for longer term, like, above 1 year. So I told you, in capital market, it's all the interest rate, um, the interest rate accrues through compounding, right? We talked about that before. The interest rate is compound interest rate, right? And in money market, it's simple interest rate. Simple interest rate. Of course, compound interest rate for, capital market. So we basically have we basically know how compounding works, right? For example, uh, um, basically it is future value 2, right? Future value at the end of year 2 is principal times 1 plus 1 plus r raised to the second power, right? And in general, uh, okay, so in general, we can rewrite it as, in generalized form, right? Future value n future value at the end of year n is principal times 1 plus r raised to n. We know this already, right? That's what we did in, topic 1. And I'll have to assume that you remember this, because if you are rusty on this, it cannot be rusty. It was just, about a month ago when we talked about this, right? In February. If you're rusty, then I suggest you go back to topic 1 and review the materials there. Also, all my past lectures are on YouTube. If you are diligent, it's only a matter of, just looking up. Then think about it. We all understand that the compounding is how the compound interest rate is used, right? How they use compound interest rate to arrive at future value. Given that, given P, given, principal, R, interest rate, and N. In other words, if these are known variables, right? They are known quantity. They are known quantity, right? And the unknown is this. Future value is the unknown. So most of the times the question was like, if principal is 10K, if the principal is 10K, and if interest rate is 10%, 1.1 for 5 years, what's going to be the future value, right? But on the other hand, we can also assume a situation where, let me choose a different, maybe something like this. Okay. And so what if future value is also a known quantity? We have 4 variables, right? Future value, principal, R, and N. We have 4 variables. Therefore, there can be 4 unknowns. In other words, what if this is the unknown? Right? What if this is the unknown? And the others are all known, right? Future value is known. R is known. N is known. But what if, P is the unknown, right? That's the second possibility. Doing this is not, finding future value is not difficult. All you need to do is just, use your calculator, and, if you do this, we can do it on Excel as well. We can do that using Excel. Why is this thing so slow? I mean, if we, it's totally not a big deal. You can simply, multiply 10,000 by 1.1 raised to 5, right? Comes to 16,105, which is not a difficult thing. We can easily find that. Was it? What was that? A 105.1. But think about it. What if we can think about a situation where future value is known, right? So like future value R and N are known, but principal is unknown. Yeah, that's perfectly plausible because suppose you need 16,105 5 years from now. Currently, the interest rate is 10%. Then how much how much should you deposit in the bank today? In other words, what kind of principal do you need to have today, right? That's a quite plausible question. Another situation is also, future value, principal, then R is the unknown. Okay, I'll just do right? Oops. What if interest rate is the unknown, right? How do we solve for that, right? But you know the answer to this already. You know the answer to this. You can't just make a connection. The next question is, of course, yeah, well, future value. I don't know why it's so difficult. Future value is known. P is known. R is known. But N is the unknown. Okay. So that means, as I said, 4 variables. There are 4 variables. So there are 4 possible questions or 4 possible unknowns that can be derived from the basic compounding equation, right? Number 1, of course, this is the basic form, and then number 2, number 3, number 4. Right? 4 possible unknowns or 4 possible questions. And since number 1 is something we already know, we'll focus more on number 2, 3, and 4, right? And then let's, let's take a look at the our Excel file, right? The Excel exercise. I don't know if you have already downloaded or not, but if you have, see, if you go to our third topic, right, topic 3, these 2 files, of course, you need to download those 2 files, and this is the, obviously, the extension, file extension is XLS, that's Excel file, right? And I want you to download that file now and open it. Okay. Open that. Let's see. Did you all download it?
The time value one?
Yeah. Yeah. So everyone has downloaded it. I need to make sure everyone has it in front of you, right? Did you download it? Everyone has it?
Let me, where is it?
We're talking about topic 3, so you must go into the topic 3.
Okay.
And then the files have no time limits, right? So they will be visible right away. You may not see. You can still see, you may not see what looks like grayed out. I mean, from my end, it can be seen. It's visible, but from your end, that's not visible because it's already passed. So that means, you must be caught up all the way. These, blue icons, right? Those are video links, right? And they are the ones they are the current and active ones. So that means you must be caught up all the way to this, right? You must be caught up all the way to this. But whatever is grayed out must not be, it must be invisible to you. That means those are already passed. So you gotta, if you didn't watch these before, you must make up on my YouTube channel.
Also, I have a question about the test, but I think I'll just ask it at the end of class.
We cannot use the, we'll get delayed, you can ask the question.
I'm going to wait until after the class ends.
Mm-hmm. Yeah, but again, it's better to schedule an appointment during my office hour, because on Monday, I have classes back to back. Right after this, then I have, at 3 o'clock, I have another class.
No, it's not. It's not like I don't need help explaining the concept. I think there was an issue with the test. I just wanted to bring it to your attention.
Yeah, well then, just to expedite everything, why don't you just email me? Why don't you explain your issue, and if I can reply by email, if it can be resolved by email reply, I will reply to you.
Okay.
If not, I would suggest that you make an appointment for my office hour. Okay, so if you have downloaded that file, then and you must have it in front of you. So here, let's take a look at row 2. So basically, how do we do it in Excel? So here, principle is we used 5 years, so let's try 5. Change, time to 5, right? Principal 10,000, APR 10%, time 5 years. So if you put that means if you put $10,000 into your bank account, paying 10% APR, annual percentage rate, if you keep it for 5 years, what's going to be the future value? We know the answer to this because we used the calculator. But let's do this on Excel. And what is column D? Column D, I'm going to get to that later. So it's principal. You must start with the equal sign, of course. It's principal times. We do exactly like the formula. 1 plus R. This is the rate. Okay. Raised to. That symbol is the I must have mentioned this in the first topic 1 as well. That's the universal machine language for raising something to power. So you're raising it to 5 years. Okay? And then hit enter. We got exactly, wasn't that the result we got? We got the result, right? We got the result by calculator. But I prefer using Excel than calculator because if you use Excel, you can. I'm gonna show you the benefit of using Excel. So now let's go to the second example, row 3, right? Now, what is M here? It looks like the same example. 10,000 principal. 10% interest rate, 5 years. But what is M? M is the compounding frequency per year. Okay. So we introduce another variable called M. I think flag is default. So compounding frequency per year. Okay, it takes time to. So that how many times can compounding happen? It can be once a year. I'm not gonna write verbiage because it takes too much time. Writing just compound. It's not that critical. I mean, you can write it down. Writing it on the screen takes my hand. It's not writing clearly or correctly. Make a mental note or write it down somewhere, right? So M can be 1, 2, 3. No, not 3, 4, or 12, or 365. It can even be more. But now think about it. If compounding frequency is 1, that means once a year, annual compounding. If it is 2, it's semi-annual compounding. Semi-annual, right? Half year, every half year, 6 months. If compounding frequency is 4, that's quarterly, right? 4 times a year. 12, of course, monthly compounding. 365 daily, right? And theoretically, it can be by the hour, right? By the hour, by the minute, by the second, even by nanosecond. By the hour, then, is 365 times 24. By the minute, and 365 times 24 times 60. By the second, 365 times, 24 times 60 squared, right? So, yeah.
Is there a specific reason why you skip 3 and other numbers?
Oh, yeah. You mean, the third equation and fourth equation?
Yeah, for M.
Oh, for M. No. It coincides with our regular calendar time, concept of regular calendar time. I mean, once a year, twice, that's annual. Twice a year, it's a semi-annual, right? Every 6 months. And then what is 3? I mean, that's 3 times a year. It's like trimester. But do we use any like trimesterial cycle?
No,
Like
it's more annual.
hmm?
Yeah.
Yeah, it's either annual, semi-annual, or quarterly, right? Or monthly, or daily. Uh, Sometimes weekly, right? We can have weekly. That's 52, of course. Then, um, but trimester, we don't use that. It's not impossible. It's not impossible, right? Uh, uh, but trimester will, involve 4 months. It will include 4 months in each trimester, and that doesn't coincide with the natural rhythm of time, right? So it doesn't. Celestial. What do you say? Uh, we just had, vernal equinox. Was it yesterday or today? Vernal equinox. Mhm. Does anyone even keep track of that? Let me just let me look it up. Yeah, yesterday was actually vernal equinox. So we have 4 seasons. We just entered spring yesterday, as of yesterday, right? Spring began yesterday. Um, So it coincides with 4 seasons, right? 4 quarters, 4 seasons, right? First quarter. Uh, Actually, we're still in the first quarter, but so I believe that explains, right? But again, mathematically, we can do trimester, right? Trimesterial compounding. And theoretically, that is possible. We just don't use it, right? So here, then if the compounding, why is it doing that? So if we use, this is, think about it, more frequent compounding. I mean, I don't know how else I could call this. That's, more frequent compounding, right? But think about it. It will inevitably, if compounding is more frequent than once a year, right? We'll need adjustment to our APR, right? First of all, if APR is 10%, that's per year, literally annual percentage rate. It's for a year. So if it is twice a year, then APR must be adjusted by 2. In other words, because think about it. If compounding is semi-annual, right, it cannot be 10% each time. Each time it will have to be 5%. If compounding is 4 times a year, right, then you cannot apply 10% interest rate every time it gets compounded, right? So every time it will have to be 2.5% if it is quarterly. Isn't that right? Doesn't make sense? So when that rate is adjusted for compounding frequency, now we call it R. So R is a generic notation, right? Generic notation, right? We call that periodic rate, and the symbol for that, so hard to write. I don't know why it is so difficult. Periodic. Literally, that means, that's the interest rate that applies each compounding period, right? Literally. So, and then think about it. Also, compounding, because we have more compoundings per year now, over 5 years. I mean, think about it. If M is 2, there will be, over 5 years, there will be 10 compoundings. Isn't that right? There will be 10 compoundings because it's twice a year. Over 5 years, there will be 10 compoundings. If compounding frequency is quarterly, right, then there will have to be 20 compoundings over 5 years. So that also brings some change to our N, because previously, think about it, previously T was in years, time was generally, in years. How many years? 5 years. So we just raised it to 5. But think about it. This needs to be changed. This needs to be adjusted as well. Because if compounding frequency is 4, there will be 20 compoundings during these 5 years. And now this is called N. Okay? So R and N are nothing new. These are the symbols you've seen so far. But these symbols are basically generic, very generic, right? It can mean anything. I mean, it can mean, let's say R can mean annual rate. So it's more inclusive. I mean, it's more comprehensive. R can mean APR. If compounding frequency is annual, yeah, APR is exactly the periodic rate. But if it is quarterly, compounding is quarterly, then you can, APR must be adjusted for that. So it will be 2.5%. So it's periodic rate. Periodic rate will be, 2.5. Also, time was, N is, actual compounding frequency, actual number of compounding. Actual number of compounding. Okay, actual number of compounding. So we understand, how these adjustments will have to be made, right? It's just making adjustments. So we go back to our Excel file and, oh, where is it? Here. So now you see this, you understand this formula, right? Future value is principal times 1 plus APR adjusted by M, right? Divided by M raised to M times T, or T times M. So principal time 1 plus APR divided by, divided by M, right? Raised to T times M. Right? Now, you might wonder, why do we have to put it into parentheses? Look, it's PEMDAS. You must put it into parentheses. Otherwise, Excel will raise it to C3 first. That will be done first. And then the result will be multiplied by D3. So then it's going to end up in a completely different result. So you must be careful about that. And if you hit enter, yeah. See the difference? It's the same principal, same APR, same years, but depending on the compounding frequency, the higher the compounding frequency, you end up in a greater future value, right? The more higher compounding frequency will result in a greater future value. And also, I will just copy and paste it into E2. You might wonder what happened. You know how to copy and paste by dragging, right? You bring the cursor to the southeast corner and just drag it up or drag it down or drag it to the right, drag it to the left. The formula gets copied. The formula has been copied, right? The formula has been copied. So here, you might wonder, it's not going to make any difference, right? It's not, because M is 1, it's not going to do anything. But this way, but it's important to keep the uniform. It's, for the consistency and uniformity, it's always, better to keep the formula uniform, right? That way you will never that way you can, take care of a large sample. You can take care of a large example or a large case. What should I say? Or a large, number of examples. Solved in a very easy, simple way. It will be very handy. So here, let's take a look at row 6 and row 6 through row 11, right? You see, this one is exactly like row 3, the same example, but I will do it in a slightly different way. So instead of, making adjustment inside the formula, I will make adjustment outside the formula. In other words, first, I added 2 columns. I added in 2 columns, one for periodic rate and the other one for N. So for periodic rate, all you need to do is just follow the definition of R as APR divided by M. There you go. And then definition of N is T times M. T times M. There you go. Then future value is it's very simple. You only need to do is P times 1 plus periodic rate, right? 1 plus r raised to n, right? Oops, I forgot to close the parenthesis here. You gotta close the parenthesis. And then we will get the same result. Oops, what happened here? Plus 8, 6 times 1 plus E6. Oh, E60 something. Instead of closing parenthesis, I actually I accidentally hit 0. So then this is exactly the result we got right here. It's the same thing. Now then, see how Excel helps. I mean, if we have like 5, 6 additional problems like this of the same pattern, we're trying to find the future value.
Copy
and
and
they
paste.
are,
Copy and paste.
yeah,
Just drag it
exactly.
down.
Because it's exactly the same formula. As long as the problems are of the same pattern, right? All you need to do is copy and drag it down, and you'll get instantaneously, almost instantaneously, you get, you can answer, you can solve, a whole lot of problems in a single shot. Okay, so this is, this is the beauty of Excel. I mean, it really, otherwise, think about it. No matter what kind of calculator you use, I mean, you have a fancy calculator, but the calculator is calculator. You will have to enter all of these all over again. You'll have to enter these inputs all over again, right? In other words, solving every problem, one at a time, all over again. And that's going to be a very tedious job. Why? It is tedious because, of course, something you could handle in a single shot, right? It's not that you cannot do it, but it takes too much time, right? It's gonna, so in this day and age, right? Who's gonna have, so, and one thing, there were some people who were actually, who were concerned about plagiarism. Isn't that plagiarize? How can you plagiarize your own work? You copy and pasted, yeah, right? This is your work. You did this, and it's just repetitive. So you copy and paste your own work. So how can you plagiarize your own work, right? That was such a silly, question. But that question, Josh Wolfson, when I demonstrated this like 20 years ago, and he was, saying, oh, then I'm concerned these days students, are very lazy and they don't want to do, any math work. And, you're teaching them to copy and paste, wouldn't that be No,
But
if you're
ultimately,
copying,
that's how you use Excel.
what?
Ultimately, that's how you use Excel.
Yes, of course. And you're not copying somebody else's work. You're copying your own work, right? And that's called efficiency, not, plagiarism, right? If you're copying somebody else's work, that's plagiarism. But you're copying your own work, right? As long as you got this right, the rest of it doesn't need to be repeated, right? All righty, so that's all the time we have for today. That's all the time. So any questions so far? Any questions?
Thank you, Professor.
All right, you're welcome. Have a great day, and I will see you guys on Thursday. Okay? All right. So I'll stop recording. All right, Alicia, take care now.
Thank you, Professor. Bye.
All right, take care, Claudia. Stop recording.